Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny Savita, and in this video, we're gonna discuss about this hybrid search in RAG. Yes, guys. So, guys, I was on break. I didn't upload any video since 5 days. Because I was busy with some other commitment and the work and all, so that's why I couldn't upload. But don't worry, now again I'm back with this video. So here, guys, I'm going to be start with a new topic. The topic basically it is related to the retrieval, right? So if you would look into the RAG architecture, so in the RAG architecture, I think we have completed till data ingestion. I will be showing you the RAG architecture and the video, like whatever video I have created related to that. Now it's time to understand the retrieval process. Retrieval process for what? For getting the context from the like getting the context from the database, and that context we are passing to the model. So we have a different retrieval technique, and in that this hybrid search. Okay, this is the basic technique, and it's the first technique as well. And after this hybrid search, I'll be talking about the different retrieval technique like naive approach or this Windows retrieval and all. And we have many more technique. Definitely, we're gonna discuss those particular technique. Now, apart from that, we have re-ranking and all. So first we collect the data, then we rank it. Okay, we give the ranks and all to that particular sentences, and after that we can re-rank also. So we have those algorithm, inbuilt algorithm and all. Definitely we can learn about the re-ranking, and that comes inside the retrieval only. Now, guys, so what all thing you will learn inside this particular session? So let me tell you first of all. So here, guys, you will learn about the keyword search. What is a keyword search? You will learn about the vector search. You will learn about the ensemble solution. If we are going to combine this both solution, so this is called the ensemble solution. Now, combining, why we are combining? We are combining it for the better retrieval, for the better context, so that we can provide the meaningful information to the LLM model. The next thing, we'll try to do this thing using the ChromaDB. We'll perform this same thing using the VB8, because VB8 is also having the hybrid search. I will be showing you that. Here we are going to be load the quantized model from the Hugging Face, so no need to worry about any APIs and all. And here, after the retrieval, we're gonna learn about the re-ranking also. So this is my main motto for this entire session. I hope this thing is clear to all of you now. Coming to the next point. So, guys, here, if you will look into the RAG architecture. So, first of all, let me give you the quick recap from this architecture and from my previous videos and all, whatever I have created. And then I will come to the solution, that what you can do inside the hybrid solution. So, first of all, guys, see, just look into the architecture, this particular architecture. Let me switch on my video so that you can get the access of the entire screen. Now, inside this architecture, you can see what we are going to do. We are going to create a RAG. So let's say I want to create a RAG and I have a data. This is my data, guys, right? Now, this data, what I'm doing, so I'm going to be convert into the embedding. I already shown you this particular process with the different framework, with the different database and all, from the different model and all, everything. Then this chunking, we are going to be convert into the embedding, and this embedding we are going to be stored inside the database. So this particular process is called ingestion, guys. Okay, now here you can see, so let's say here is my user who's asking the query from the chat interface. So this query actually is going to be convert into what? Into the embedding, right? And then based on this particular embedding, we are going to perform the similarity search from the database. So this process is called the retrieval process. Okay, retrieval process. Now here what we are doing, so we are going to be perform one more process, that is called ranking. So we are going to provide the rank. Each and everything I will show you in the Python itself, so no need to worry about it. I will be showing you the Python implementation. So we are doing a ranking, and based on that, let's say we are doing ranking. Now top 3 result we are passing to where? We are passing to my LLM. Okay. Now based on this particular context, so this is also called context. My LLM is deciding my generation. So whatever output is going to be generated, it is going to be decide that particular output based on what? Based on this context. Okay, I hope this thing is clear. Now, if you will look into my playlist, guys, so let me show you my playlist over the YouTube itself. So this is my YouTube channel, guys. If you haven't followed so far, please do it, because I'm uploading a video on a daily basis. Yes, I was busy in the previous days and all, so I couldn't, but yeah, most of the time I'm trying to upload within a days or within 2 days and all. So if you will go and check with my playlist, so here I created one playlist on this rag itself. Okay, now inside the rag, just look into this particular playlist. I try to cover each and everything, each and every framework, whether it's a langchain, llama index, haystack, whatever framework, guys. And I try to create a different application using the different model and the different databases. And here, guys, not this one, I try to cover this multi-modality also. Okay, multi-modality in terms of data, in terms of embedding, in terms of storage. Okay, so here, if you will look into this particular playlist, so I recorded 20 session, and those session basically it was around to this ingestion only. Means here I was not focusing much on the retrieval part. So whatever naive approach is there of the retrieval, I was just trying to perform that. And here now from this particular video, I'll be focusing on the retrieval part as well. Different type of retrieving technique. So let me tell you guys what all type of retrieval technique could be. So here I can write those technique, and then later on I will try to show you the implementation in the Python. So the very first technique, which is called the naive technique. Okay, naive technique, or the technique which we have performed so far, naive retrieval. The second one, which is called window search. Okay, so here I can write a sentence window retrieval, or this is also called window search. Retrieval. Now the third type of technique, which is called, so here let me write the third one. It is called self query retrieval. Self query retrieval. Okay, now the fourth type of technique, which is called parent document retrieval. Okay, parent document retrieval, or this technique is also called small to big retrieval. Now the fifth type of technique, which is called, tell me, which is called HDE. Okay, if you will search over the Google, you will be getting this HDE. That is called hypothetical document embedding. So we'll talk about this also, hypothetical document embedding. And here, see, as of now, we're going to talk about the hybrid technique, which is a combination of what? Which is the combination of this naive retrieval plus keyword search. I hope the idea is clear now. Okay. So let's look into the practical, how we can do it, how we can perform it. So here, guys, here I have opened my collab, and inside the collab itself, we are going to perform each and every practical. And in between, whatever theoretical thing will come, okay, and definitely I will try to explain you over my blackboard itself. So let me change my runtime, and I'm keeping the GPU itself. So here, guys, I'll be showing you with the Chroma DB. In the next video, I'll be talking about VB8 as well. VB8 with re-ranking, coherent re-ranking. We have other re-ranking technique and all, and every re-ranking technique I will talk about inside this inside the upcoming tutorial and all. And yes, a few I have recorded, few I'm going to record. I'll be uploading on my YouTube channel soon. So the first thing, guys, what we are going to do here, we are going to be understand about the keyword search, how we can perform it. Now, regarding this keyword search, I will give you the more detail how basically we're gonna do it and what is the use of it, because it's not a new technique, it's an old technique which we were using. Okay, it's been a decade, right? So this Google itself has introduced this this one keyword search technique with respect to their web pages and all, and they have introduced two things. First is TF-IDF, the second is page rank. Okay, by using this both technique, they were trying to perform the search. Okay, so whenever I'm going to be search anything over the Google engine, they were trying to they were trying to give the results and all. Okay, the web pages in the form of web page and all. So first of all, let's do one thing. Let's try to implement this thing in a Python itself. So what I have few libraries. Let me keep this libraries over here, and along with this library, I have couple of document as well. So these are the sample of document which I have written by myself. So this is the list which is containing the sample document. Keyword are important for the keyword based search. Document analysis involve extracting keyword, and here keyword based search relies on the sparse embedding. Okay, sparse embedding, dense embedding, everything we'll try to discuss. Just a wait. Every idea I will try to give you. So this video is going to be around 25 to 30 minutes, and within that we'll try to understand each and every part of this keyword search or this hybrid search mainly, and that this keyword is also involved. So here this import statement wise, I'm importing this TF-IDF vector and this cosine similarity and this numpy array. So why I'm using it, why I'm using this TF-IDF and all, everything I will try to explain you, so don't worry about it. Now what I'm writing, guys, so here I'm going to write my query. Okay, this query is nothing, it's a keyword only, which I'm going to be searched inside where, inside this particular document. So my query is going to be what? So here my query is keyword hyphen based, okay, and search. So now this is my query and this is the word which I'm going to be searched inside this document, and I will try to find out the similarity, how much a similarity this word is having with this particular document. Now let me run it, and yeah, it is fine. Now one more thing I'm going to be write over here, that is what? Okay, re, that is regular expression. Now here I'm going to be clean the text, so whatever text I have in that particular text, if I'm having comma, punctuation or uppercase and all, I'm going to be clean all those things. So for that I have written this simple method. Now I'm passing my document to the simple method, and then I'm going to be clean it. So first I'm going to be convert each and every word into the lowercase, and then I'm going to be remove the punctuation, okay, whatever punctuation is there with this with the help of this line. Now let me do one thing, let me remove the data. So for removing the data, guys, here I'm going to be write one list comprehension. Inside the list comprehension, here I'm going to be write one for loop, and I'm going to be collect the data from this document itself. So here is my document. Now what I'm doing, I'm passing this particular document to this method. So pre-process text I'm calling over here, and then in return I will be getting the, tell me guys what I'll be getting over here. I'll be getting the pre-processed document. So this this particular data I can keep inside the pre-processed document. So let me keep it. Okay, perfect. If I'm going to run it, now let me check with the pre-processed document. So it's telling to me name pre-processed text is not defined. So let me run it, and then I think it is going to work. So here is a variable pre-processed document, and inside the pre-processed document, now check, we don't have any full stop or something. Each and everything in a lowercase, so that I won't find out this keyword sensitivity and all. Because if I'm writing keyword, okay, with a small k, and if I'm writing keyword with a capital K, so this English, this particular like interpreter and all, this compiler, okay, it will take it in a different manner. Okay, so it's not going to understand this in a same way. This keyword with a capital K and keyword with a small k. So that's why this pre-processing is required, so that I can remove this case sensitivity. Okay. Now a pre-processed document is there. Now what I will do here, I am going to be perform one more thing. So first of all, guys, let me show you this document, how this document looks like. If I'm going to execute the for loop, so this is my all the document. Now here you can see what is my keyword, guys. Here is what, here's my keyword. Now on top of this document, I'm going to be perform, tell me, TF-IDF. Okay, I'm going to be convert this particular document into the TF-IDF. So pre-process query, what is the name over here? I think I just written query. Let me write over here this query. And guys, this query also I have to convert into what? So here you can see keyword based search. I think it is fine, right? Or what I can do, I can pre-process it also, because unnecessary I will be facing the issue later on. So let me pre-process this particular query, and here I'm passing this query, this keyword, and let me check with this variable. So what I have my pre-processed query. Great, guys, keyword search, and see, here also you will be find out the keyword and all the same type of keyword inside the document. Now, let me do one thing. Let me convert this vector, sorry, this document into what? Into the vector. And the vector is going to be a sparse vector, okay, which I'm going to be create by using the TF-IDF. Now, let me do one thing. Let me create a vector. And first of all, I'm going to be create object of this TF-IDF vector. So let me create an object of this TF-IDF vector. And here, this is going to be my vector, okay. Now, what I will do, I'm passing my data, complete data, to this object, okay. So here is what, here is a vector. Now this object actually it is having one method. Method name is what? Fit transform, transform. And now to this particular method I'm going to be pass my documents. So docu, MENTS. So I hope guys this is perfect. If I'm running it, if I'm executing it, so see it is telling to me documents is not there. Maybe spelling is not correct. Let me take the document, and here the document is going to be. So this is my document guys, and here is my pre-processed document. I think I need to pass the pre-processed document, not that document. So this is my pre-processed document, and finally what I'll be getting my vector. So let me execute it, and yes, perfect guys, I'm able to get the vector. So let me keep inside the x. Okay, and if I'm calling this x dot to array, I'll be finding out my vector. So all the vectors is here. See, I'm having a 4 document. It is converting into the 4 TF-IDF vector. Now what I'm doing, if I want to collect the first vector from here, so how I can collect it, let me show you. So instead of like this, I can write simply 0. So this is my first sentence, first vector. Now the same thing I can apply over the keyword also. So here I can transform this keyword over here. So let me write this vector, and instead of this fit transform, I'm simply going to write this transform only. So what I have my transform. Now what I'm passing my query. Okay, pre-processed query. Let me take this pre-processed query, and this is going to become a vector. I think you know how this TF idea works, right? So this is going to be my query underroot embedding. As of now, I'm just showing you the keyword search, and then I will be showing you the like this vector search, and then finally I will combine this both solution using the langchain and all. Here is a raw implementation of it. That's it. So this is my query embedding. Now if you want to check the vector, so simply you can look into the vector also by using this method to array. Okay, so here I can execute it and see I'm getting this array of it. So guys, here TF-IDF working. Now we have one more updated version of the TF-IDF, that is called VM25. So this VM25 is algorithm for generating the sparse vector. Sparse vector means what? So in at most of the places you will find out the 0. Okay. And here guys, we are not using VM25. We can use that also. It is already there over the Hugging Face. Or what I will do in the next implementation, I will use this VM25. Here I am using simple TF-IDF. Now, sparse matrix means what? You will be finding out 0 at most of the places over here, right? Now, guys, first of all, let me clarify a few things related to this keyword search and all, because that is very much important. So, let's say if we're going to talk about this keyword search, so why we use it? We use it for the information retrieval. Keyword search. For what? Information retrieval. Now, let's say we have a sentence. My name is Sunny. And here I'm searching one word. Okay. Let's say my word is what? Sunny. So this word is available inside the sentence. Yes, it is available. Let's say I'm having one more word. The word name is what? Bunny. Right? Now this word is available inside the sentence. No, it is not available. But as a human, we can identify it by seeing the language, this document, and these words. But how I can prove it mathematically? So for the mathematically, definitely I will have to check the mathematically. I will have to check with the similarity score and all. So similarity between this word and this sentence. Now there this cosine similarity comes. Okay, I can perform this cosine similarity between what? Between this word vector and this like this particular vector. Okay, whatever vector which basically which I'm going to be generate with this sentence. Now here similarity. So with respect to this, see, here is what? Here is my word. So regarding my word, I can generate the vector. Okay, now related to this particular sentence, I don't want to be generate the dense vector. So that's why I'm not using this Hugging Face. Hugging Face sentence transformer, which is using the advanced concept that is called the sentence transformer, using the different transformer based model like T5, Bird, GPT, and all. So I'm not using this Hugging Face sentence transformer. Instead of that, what I'm doing, I'm going to be use this TF-IDF or BM25. BM25. Now, why I'm doing it? Why I'm using this TF-IDF or BM25? Because see, whenever I'm BM25 is a updated version of the TF-IDF only. Now let's say with respect to the Sunny and this sentence, my name is Sunny. What I have to do? I have to create one vector. So here my motto is what? Here my motto is keyword search. Okay, keyword search. KWS means what? Keyword search. Now, what I want to do? See, I want to take a vector. Okay. Now this vector actually it is having a detail of this particular sentence, right? So what I'm doing? See, this is my document. Now first of all, let me clarify a few more things with respect to this particular like document corpus and all. So the entire text whatever we have, okay, so that entire text or entire paragraph graph, it is called the corpus. Let me write over here corpus. So whenever you are going to be fetch any data from the internet, that complete data is called corpus. Now from this corpus, I can collect the document. Okay, I can generate the document of sentence. Both are same. Now from this sentence, actually, it is a collection of what? It's a collection of word. You can say tokens. Okay, anything you can say word, tokens, or you can say vocabulary. Vocabulary. So what we do, guys, in TF-IDF vector. So here is my corpus. So from the corpus, actually, we create this vocabulary. Vocabulary is nothing, it's a collection of the unique words, and we create this document or the sentences, right? So here is what? Here is my document. Sorry, not this one actually. This is my document. You can just assume. Here I took one. Here I took it from the corpus. Now, what we do? We create the vocabulary. Vocabulary is nothing. It's a collection of the unique words. Okay. So I have what? I have my unique words. So now, let's say this is what? This is my dimension of the vocabulary. And here, with respect to this particular document, I'm going to be create. What I'm going to be create? I'm going to be create a vector. Okay. So here is what? Here is my dimension of the vocabulary, and the dimension, okay, dimension of the vector, it will be equal to the dimension of the vocabulary in the TF-IDF, in the document metric that is called bag of words. In bag of words, we calculate the frequency. Okay, but in this TF-IDF, we always calculate TF into IDF, TF into IDF with respect to every words. So whatever words we have inside the vocabulary, with respect to that, okay, we are going to be calculate this TF into IDF. I will start one series that is that I am thinking in this month itself. So NLP fundamental. So let me just tell me, guys, how you want it in live sessions or in a recorded mode. You can let me know, and definitely I'll be creating for all of you. So there I can clarify this each and everything related to the TF-IDF and all, because it's a very deep topic. I can talk about it like more than half an hour on and all with this like a specific topic only. I can take a multiple example and I can show you. So let's try to understand just a overview and all, so that you won't face a difficulty later on with the VM25 also, and why we are taking this sparse metrics. Okay. So here we are taking this word. Okay, word is nothing, it is representing the vocabulary, and with respect to the sentence, I'm calculating this TF-IDF value. Okay, so here is my word, means vocabulary. Now with respect to this each and every word, okay, which I'm so here is what? Here is my word, right? And this word basically based on what? Based on this document, what I'm going to be do? I'm going to be calculate this TF into IDF value. Now what is a TF? So TF is nothing, it is called term frequency, and IDF is nothing, it is called inverse document frequency, right? If you will look into the formula, I can show you the formula of it. So here let me copy the image, and this is the image, guys. See, so TF-IDF. Now number of time the term appears in the text. Okay, this particular terms which is appearing number how many times, and total number of terms. See, here they have clearly written it, total number of terms. This is called term frequency. I think it is visible to all of you. If it is getting blur, you can zoom in. Okay, so now the second one is what? So here it is called IDF. IDF means inverse document frequency. Now just see the formula of the inverse document frequency: total number of text in the corpus, okay, and number of text counting number of text basically which is containing this particular term. Okay, this term. So likewise, we are going to be calculate for each and every term with respect to this sentence, and I'm going to be form my TF-IDF vector, which is keeping, okay, what it is keeping? Tell me. It is keeping the keywords, right? It is keeping the vocabulary. So here is what? Here is my sparse matrix, right? Sparse vector or matrix, anything you can say. And what I have my keyword. With respect to this keyword also, I can generate my vector. How? Because this is the vocabulary, right? So wherever I'm having this particular keyword, I can write this TF into IDF, and wherever I don't have, I can simply write the 0000. That's it. Okay, and this was the old method. Now we have the new method. New method means what? A vector, vector search and all. So inside the vector search, what we do? So let's say we have a sentence. So with respect to this entire sentence, we create the vectors. Okay. Now whenever we are asking any sort of a query, so this query also it's a vector, or let's say it's a word, whatever is there. So with respect to this also we create a particular vector, and this vector is called the dense vector. Okay, dense vector, and this vector we are going to be create using the transformer, right? So we have different transformer based architecture like BOT, T5, GPT, and the other architecture, Mistral, Llama, and all. So each and every transformer architecture is having their own embedding model as well. Okay, so we have a sentence, and with respect to that particular sentence, we are going to be create a vector, and this is the dense vector. And between this one, we can perform the similarity search and all, like cosine similarity, dot product, Jacquard similarity, or any other similarity. Now, if you will go and check with the Google, so just write about this sentence transformer. So let me write over here a sentence transformer. Now the sentence transformer, it will give you each and every model with respect to this transformer. Uh, for what? For converting the sentence into the embedding. So later on you can perform the vector search on top of it. And if you want to create a sparse vector, so that basically we can create by using the TF-IDF and BM25. So these are the this is the code which you can use, and there actually you can keep any sort of a model. So here once you will scroll down, see you will find out more than 125 model. It's an open source model like BORD, T5, XLM, Roberta, Distilbird, okay, Sentence T5, many more model you will find out, right? So you can utilize this model and you can convert your data into the embedding. And later on, definitely I'll be showing you if I'm going to be start with the fundamental of NLP series. There I will be using these things only. Now coming to the point. So here I hope this thing is clear to all of you. Now let's try to understand in terms of practical Python code. So here I'm having the query, and this tell me here is what? Here is I'm having a vector. Okay. Now what I'm going to do? Now I'm going to perform the similarity search between what? Between this keyword and this document. So for that, guys, what I have this code. Let me keep it over here. So this is my X, and here is y. Here is my query embedding. Now simply I'm passing to this cosine similarity. That's it. So let me check the similarity. What will be the value of the similarity? So here I'll be getting the similarity. See, so 0, 0.500, and 0.48. Now see, here is the similarity with respect to this document, right? And here is what? Here is my keyword. Now if I want to rank it, rank means what? Which document is having a higher similarity? I can simply rank it, right? So I'm having that code also. Let me show you that particular code. With that, we can perform the ranking. So here you can look into this particular array, right? So this array actually, it is simply showing you. Just look over here. Just a second. Let me show you. Let me highlight this particular part. See, guys, here if you will look into this matrix, now just see 0.50, the second document is having a highest similarity. This 0.8, 0.48, basically it will come to the second part, sorry, at the second place. And here's the 00, so you can keep it anywhere, right? Now here by using this particular code, I can rank to which one? I can rank to my document. So what I'm doing, so this is my similarity, which I'm simply passing to this mp short argument. Now see, over here if I'm passing to this one, what I'll be getting, let me show you this one. So if I'm passing it over here, so I'm getting this 0 2 3 1, right? So it is giving me a rank. Okay, now it is giving me a like a rank, and here basically what I can do, I can reverse it. So I can reverse it, and basically what I will be getting, so see, let me show you what is this. Here 0 is this one, 1 is this one. Okay, then here is what? Here is my 0 again, and then sorry, 0 1 2, and this is what? This is my 3. If I'm converting into the rank, so this is my first rank, means this first actually it should come at the first place. This is my second rank. Okay, this 3, this 2 means what? 0 1 2, this one, and this is what? This is my 3. Okay, now what I want a reverse. I want reverse of it because it is giving me in a ascending order, right? I want a reverse of it because this one actually, this one is having a higher similarity. So by using this one, this code, okay, this is my reverse, and here is I'm doing a flattening of this particular array. Now see what I'll be getting. So this is my ranking. See, let me show you the rank indices. So here, just look over here, look into the rank indices, and see, this is my first sentence, means 0 1. okay, which is having a first position, then 0 1 2 3, this is my second position, 0 1 2, this third one actually it is having a third position, and then this is the fourth position. I hope you are getting. Now let me take the corresponding document also with respect to this indexes and all. So here what I'm doing, guys, just a second, let me take a corresponding document from here. So these are the document, guys. So let me run it, and here you will be able to find out the document. It's saying rank document, it is not there. Okay, so I think I have to keep somewhere else. Just a second, let me keep over here this rank document. So I'm keeping it inside this code, and see document rank indices, and here is what, here is my rank document. Now let me check, guys. So if I'm going to be execute this part, so I will be getting my rank document. See, rank 1, keyword are important for keyword based search. Now, what was my query? So here, if I'm going to be write my query, guys, see, here is my query is what? Keyword search. Okay. So let me check a query. What was the name of the variable? The name of the variable of the query only. So here I'm going to be showing my query. QUERY. Okay, fine. QUERY. Now see, guys, here if you will look into the query, so keyword based search. Now in this sentence, this keyword word actually it is coming 2 times, so that's why it is having a first position. Now in the second one it is coming 1 time, okay, but this is this whole word is coming, so that's why it is, I'm getting a second like rank over here. Then inside this one only keyword is there, okay, that's why it is like getting the third position. Now here this inside this particular sentence we don't have keyword, so that's why it is coming to the fourth position. I hope you are getting this entire code. Okay, once you will rerun by yourself, definitely you will be having an idea that what I'm doing. Just rerun it, just try to understand with my words and all. Now coming to the second part over here. So if I want to perform the vector search, how I can do it? So for the vector search, guys, again, see what I did. I am not going to be create a vector using the sentence transformer and all, word and all. But yes, we can do it over here. What I did, I took a basic vectors over here. This is my vector, which is representing to my sentence. I just assume it. It's my dense vector. Dense vector means what? A dense vector actually, there you won't be able to find out the zeros. Okay, this each and every like numbers which you are seeing, it is representing to the feature. Okay, this feature basically how it is getting created through the neural network. If you know about the word embedding, word to back actually, if you know about the word embedding, BERT embedding, then definitely you will be getting this point. But again, I'm saying in the upcoming session, in a NLP fundamental session, I'll be talking about it. So what I'm doing, see here, let me run it, this document embedding. And now what I'm going to do here is what? Here is my query embedding. So now simply I can do one thing. I can perform the cosine similarity. And based on that, what I will be getting? I'll be getting my, here I'll be getting my, tell me guys, similarities. Now I can rank this particular similarity, so I will be getting my rank indices, and here is what, here's my rank indices. Now finally I can rank this particular document 1 2 3. So the rank which you are seeing now, like top 3 top 5, so from here itself, like this only we are going to be fetch the document, okay, based on this rank and all. Internally this code is working, this simple Python code. I hope this thing is clear. Now see, guys, if you want to perform it on a real data, like I did it over here with respect to this document and all, so you can take it as an assignment. What you can do, I'm giving you this particular document. Okay, so here I'm pasting. Now with respect to this one, you can perform the embedding. Okay, so here I can keep it, and you can take any sort of a model from where, you can take any sort of a model from the sentence transformer. I'm giving you this link also, and then on top of it you can perform what, on top of it you can perform this embedding, right? So this is what, this is my this is the link of it. Now coming to the next point over here, see, we understood about the keyword search, and we understood about the vector search over here. Now in the next part, what I'm doing here, so here actually I'm going to be perform the same thing, right? So I'll be loading the real data from the PDF, and on top of it, right, on top of it actually we are going to be perform this ensemble search, means this hybrid search, vector search and the keyword search. I think you got to know the fundamental. Now we are doing the same thing using the langchain and chroma db, and you will be getting the inbuilt code over here. Okay, that's why first I shown you this fundamental and I explain you this each and every detail of it so that you can understand easily. If you have any confusion and all with respect to TF-IDF, definitely I'll be clarifying the upcoming sessions and all in the fundamental of NLP. Yeah, now let's try to do one thing. Let's try to perform the same thing using what? Using one real-time document. Okay, if I want to create a rack on top of that real-time document, how we can do it? So first of all, guys, I will be required the document. So let me upload the document over here, which I kept inside my folder. So here is the document, guys. Let me give the let me upload it over here. This one, right? Retrieval augment generation for NLP. It's a research paper, which I can keep it over here. So let's try to perform the code over here. In the next video, I'll be showing you using the WebP8. So first of all, what is required? I required a data after uploading it. So let me take a path of it. So here my path is going to be this one. I'm going to be keep inside this doc underscore path. Now, after keeping a path, what I'm doing here, so this is my path, and now I'm going to be install this PyPDF so that I can read this document. I will just take 10 more minutes, and guys, yes, I will be completing it. So PDF. Okay. Now, okay, fine, guys. So here it should not be like this. It should be exclamation mark, and yes, we'll be able to install it. Now, after this one, guys, one more package is required. That is what? Pip install langchain community. So langchain, if you don't know about this langchain community, langchain, different variant of the langchain, you can go and check out with my previous video. Already I have clarified over there. So community, okay, it is fine. So let me run it. Let me execute it. It is installing. Now the next thing is what, guys? After installing this one, here I have to import this PyPDF loader so that I can read this particular PDF. I'll be showing you the document, what we have inside the document. Let me write all the codes and all, and then definitely I'll be coming to that. So here is what, here's my PyPDF loader. Now I can simply read the document. So whatever document basically I have I written the path now the document, that a particular document I'm going to be load over here, and here is my object name. That is what, that's a loader, LOADER. Fine, loader is done. Now I can simply call the load on top of it. So my loader is will load the data. So what I have my data now, and this particular data I can keep somewhere. I can keep inside the docs. So this is my data, guys. Now, if you will look into the data, let me show you the data, how the data look like. So let me do one thing. Let me show you the data. I just kept it inside this document. And this is my research paper. Research paper name is what? Retrieval augment generation for NLP. It's a very famous research paper in the field of brag, and definitely you should learn it. Definitely you should read it if you haven't read this particular research paper, right? RAG for the intensive the NLP task. Everywhere you will find out the interpretation of this RAG research paper now. Got it, guys? So we'll ask the question to my model based on this research paper only. So now what I can do? So here, this is fine. Now let me do one thing. I have loaded the data. Now I can convert into the tokens. Okay, sorry, this chunks, because that is very much important. So here for that I'm using this recursive text splitter, and this already we have learned so many times. So again, I'm not going to be explain you. Now here what I have my splitter. So let me keep my like chunk size 200, and here the overlap 30, and splitter, this is going to my object. Okay, now what I'm doing, I am passing my data to this particular splitter, and here what is the method which I'm going to be called split document. So here see, I'll be getting my chunks, right? So chunks is fine, you can look into the chunks, and every chunk is having a size which is 200 tokens. And chunk overlap means what? So let's say this is our first chunk, this is my second chunk. I'm just going to be overlapping from last 20 words, sorry, from last 30 words, right? That's the meaning of the chunk overlapping. Now coming to the next point here. So chunk overlapping is fine. Now coming to the next part where I'm going to be load the model. So the first model which is required, that is Hugging Face embedding. Okay, embedding model is required. So let me import this one. And then guys, here Hugging Face token is also required. So here is my Hugging Face token. Now how I collected this token. So once you will go through with the Hugging Face, first you need to do sign in. If you haven't done that, first sign up, and then you will be getting the token. Now inside, go inside the setting, and here click on this token, access token, and see you can access the token over here, read, write and all. If you are writing anything over the Hugging Face up, then you need to create this write token, otherwise you can create this read token only. Now what I'm doing, so here Hugging Face token is fine, and this API embedding is fine. Now here I'm going to be load my embedding model, guys. So this is my embedding model. Let me show you. So embedding model name is what? BGE base ENB 1.5. It's an open source model. It is for the embedding. So I hope it is perfect. Now one more thing is required, guys. I told you for keyword search, actually we are not going to use this dense embedding. We are going to be use the sparse embedding, which is created based on the vocabulary, okay, words only. So here let me do one thing. First of all, let me install this chroma db, because this is required over here. Now the next thing is what? So here I'm going to be use one more thing, guys, because after this one I have to load the model as well. So let me show you one more thing over here. See, here is what? Here is my chroma, guys. So let me import the chroma, and after importing the chroma, guys, one more thing is required. So let me take this chroma, and here I'm going to be call what, guys? Tell me. From document. Okay, this is the method which I need to call from document. Now here I'm going to be pass my chunks, means my data, and then I'm going to be pass my embedding. So it will convert into the embedding. Okay, this particular chunks. Now I can keep inside the vector store. So this is my what? Tell me, guys. So here I've created an embedding with respect to this chunk and all. I haven't created my sparse vector. I just created my dense vector. Okay. So this is done. Now the next thing is what? So here actually I'm going to be perform this. Let me show you what I'm going to be do. So here I'm going to be write this vector store dot as retriever. I'm going to be use this vector store as a dot as a retrieval only. And here search keyword is equal to 3. Okay, search KWARGS is equal to 3. Okay, because here what is the meaning of it? So the meaning is very simple. I'm going to be fetch 3 document. Okay, 3 this k equal to 3 is nothing. 3 retrieval document. So vector store retrieval is ready, and now if I'm going to be show you with this retrieval, so here you will be able to find out what I'm getting, guys. Here is my object. Okay, now I can pass this particular object. So whenever I will be like using it, whenever I'm going to be invoke it, whenever I'm going to be find out the similarity search, I'll be getting what? I'll be getting the top three document, right? Now the next thing is what? So here, guys, I want to perform the keyword search also. So for that, this VM25 is required. Now again, I'm saying it's a updated version of the, it's a updated version of what? It's a updated version of the TF-IDF only. Now what I'm doing, so here I'm going to be like import this two thing. First is what? First is this Ensemble VM25 retriever, and Ensemble Retrieval. From where? From the langchain itself. Now the next thing is what? So here I'm going to be pass this chunk, okay, to this VM25 retriever, so that I will be able to create my sparse embedding over here. I think I've shown you what is a sparse embedding. Now keyword retrieval is there, so which I got. Now I can decide the value, how many how many sentence we want. K is equal to 3, means based on the similarity search between the keyword and the document, means sentence, I want top three sentence. Okay, rank, top 3 rank. Getting my point? So here is what? Here is my like value which I'm going to be assigned over here. Now what I have to do, so here, guys, now is the very important thing. Now here inside this particular thing, you'll find out, see, I'm passing everything to what? To my ensemble retriever. So the first is what? First is my vector retriever for what? For my vector based operation. One vector, okay, dense vector, and the second vector, right? So with respect to the sentence, I can create the vector. With respect to word also, I can create a vector, and it's a, tell me, this vector which I'm going to be create by using the neural network. Now here is what? Here is my keywords retriever. So this keyword retriever, actually it is based on the sparse embedding. Okay, sparse vector, and this sparse vector we are creating using the TF-IDF or VM25. So specifically we use this sparse embedding for what? For the keyword search. Already I told you the reason. Now here is what? Here is my retriever, and see, I have assigned the weight. Now what is the formula of this weight? Okay, what is the like agenda behind this weight? So let me show you. Here I kept one screenshot, and definitely this screenshot will help you a lot with respect to this ensemble and all. So just a second. I'm providing you this screenshot, guys, and here I kept it. Just a second. Fine, this one. See, so here this is a formula, guys. Now just try to understand this particular formula. So if I want to calculate the hybrid score, okay. So before, if you will look over here, if you will look into this particular code which I created, or okay, so without any predefined class and all. So now over here, if you will find out, so I was calculating the similarity score using the cosine similarity. And this is what, this is my similarity value, this one, these are my similarity value, right? Now we are ranking it, and here, yes, this is what, this is my rank. I hope this thing is clear to all of you. Now see, here I'm getting my score. So this is what, this similarity is nothing. If I will show you with respect to this vector, also dense vector, so you will be able to find out the similarity value. Let's say this is my similarity value. Okay, I hope this thing is clear, this similarity value. Now coming to the next point over here. See, so I'm having a similarity value of what, this is sparse. I'm having a similarity value of what, this dense one. Okay, this is with respect to keyword, and this is with respect to this dense. Now I have to provide the value. So because this is my ensemble method, ensemble or hybrid method. So what I will be getting, I will be getting my ensemble score or hybrid score. Ensemble means what, more than two. Okay, two or more than that. So here what I have two method, sparse score. Okay, I'm having two score, sparse score and this dense score. Now this value, so to which value actually I have to give how much weightage, so that I am going to be decide with this alpha, right? So let's say here, if I'm writing alpha is equal to 1, so I'm just giving this dense score, means I'm just doing everything based on this vector search only. Now here 1 minus 1, automatically it's going to be 0. Now let's say to this alpha, actually I'm providing 0. Okay, over here I'm providing 0, means I'm removing this dense score. Everything I'm doing based on what, based on this sparse score. Getting my point? Ranking and all, everything I'm doing with that. Now here, if I want to make a balance between, so what I can do, let's say I want to, I can pass over here 0.5, and here is what, 0.5. Okay, so I'm providing like equality to both score. Okay, both similarity score. Now let's say if I want to provide more like weightage to this one, to dense score, I can write over here 0.7, and here automatically it will be 0.3. So the less weightage I'm providing to this sparse score, and more weightage I'm providing to this dense score. I hope it is getting clear that how we can make the equality, okay, between what, or how we can regulate this like ensemble score. Based on that, we are going to be final the result, okay, rank result. I hope this thing is getting clear. Now, hybrid score automatically I will be getting. So let me do one thing. Let me run this particular part. Okay, I already run it, and here I have assigned the weightage. So to the first one, to the vector retrieval, I am passing 0.3, and to the second one, to the keyword retrieval, I am passing 0.7. So directly I can assign like this, and the VBA search you will find out. I just need to pass the alpha value, okay, and based on that, I will be fetching my final result. So retrieval is ready. Now what I have to do here, so I have to get my model, because at the end I have to showcase the result using what, using the LLM only. So here is what, here's my model guys, and I'm going to load the quantized variant of the model. So let me install a couple of things over here which is required for this model, the quantized variant of the model. First is this bits and bytes, and after this one, this accelerate will be required. So let me take this accelerate also. So here I'm going to be run it with this two. Actually it is very important if I want to like run the quantized model in my GPU. Okay, okay guys, so here you can see I have installed this particular library. Now one more thing I would like to tell you here. See, for this one, if you want to use this bits and bytes and this accelerate, so you should be enabled with your GPU. If you are not using GPU, in that case it will generate the error, because it is working on the GPU and it is managing the GPU. Okay, now if I, after this one, after installing this library, I written this particular code. Now let me explain you. We just have a couple of line only. So I'm going to be import this torch, and then this auto for auto model for casual LLM, then auto tokenizer, bits and bytes, and pipeline. So these many like module we are going to be import from the transformer, and then we are going to be import this Hugging Face pipeline. Okay, now let me execute it, and it's fine. So here is what guys, here is a like method which I have written for loading the model. I'll be passing the model name, and this is the configuration for what, for the bits and bytes. So I'm going to be load the quantized model, the 4-bit model. Okay, and here you can see this is my model name. Let me show you the model name where it is. I think I kept it over here itself. So this is my model name guys, Jffer 7v beta. Now this Jffer model I'm going to be I'm going to be download. So here see, this is the name of the model, and here is the torch.b float 16, and here is a complete configuration. Okay, so this is the entire thing basically I have mentioned with respect to what, with respect to the quantization. So this is a complete quantization configuration, and this is the model name for the downloading it. Now I'm going to be load the tokenization also, because before passing the data, to the model, I have to do the tokenization. Okay, so tokenization with respect to that particular model itself. So every model is having their own tokenization. If you will look into the transformer architecture, you will find out the first place what we are doing, we are converting the data into the tokens, means a token embedding. Then we are doing a positional embedding, and then finally we are passing to the like self attention, and then to the neural network. So tokenization is very important with respect to that particular model. Now here is what, so here I'm going to be load my model, sorry, I'm going to be load my tokenization. So this is my tokenizer, and here I'm going to be load my model. So my model is done, so both I loaded. Now one more thing guys, here I would like to tell you, so I'm going to be use the chroma db. So chroma db actually provide you three variants. First variant, directly you can configure over the cloud. The second variant, you can it's a in-memory database, so here in the local disk actually it will be available. Now the third one is what, RAM based. So here in memory, okay, inside the memory, inside the RAM itself, the database has loaded, and where it is storing all the data and all. So whenever this RAM will be destroyed, means the RAM, I will stop this particular process and all, I will delete the runtime. Those data will be gone. Those whatever data I'm going to be stored there. So it provides you the three variant, and we are using the third variant. We are going to be store the data inside the RAM itself. So guys, don't worry if you are not able to see any data over here and all. So we are not going to be we are not going to be create the index inside the memory itself. So I got my model. Now I created my pipeline, guys. So here is my pipeline name. Here is my model name, tokenizer, and this is the other information. Okay. So if I'm going to be executed, so here you will find out that my pipeline is ready. Now, I'm passing this to my Hugging Face pipeline, this one, and my LLM is ready. Now, guys, I'm going to be create my chain. Chain means what? Chain means I'm going to be combine all the component. So here is what, here's my a normal chain first of all. So let me show you the normal chain where I'm passing the vector store retriever. Means I'm not passing my ensemble retriever, it's my dense vector retriever. Okay, sorry, dense based on a dense vector we are going to be perform this operation. I think you know already. So this is my normal chain. Now here I'm going to be create one more chain, guys, that's going to be my hybrid chain. Let me show you the hybrid chain, retrieval qa form chain type. Here is what, here's my LLM. Here is my chain type. Okay, there's a stuff means what, we are stuffing the knowledge over there, these like component and all. Now here is what, retrieval. This is my ensemble retriever, means both I'm going to be combined keyword and the vector store. Now here is what, here's my hybrid chain. Now I can invoke it. So first guys, I'm going to be invoke the normal chain, and let's see the output over here. So here I'm going to be invoke the normal chain and see the result. So if I will show you this response, you'll find out this response in the dictionary format. So here let me print it, this a particular response, and then a final result. So each and everything, each and every detail you will get. Now guys, see, whenever we are talking about this chains, okay, langchain chain, so you will find out the different type of chain. Retrieval qa chain, this is a simple one. Now we have other chain as well, and apart from this one, see, let me show you. You can simply search over the Google itself and you will be getting it. So langchain chains. Okay, so here I'm going to be search in front of you only, and see guys, created a stuff document chain, created OpenAI runnable, and created a structure output, created a SQL query chain. Okay, these are the chain, and these are the like chain previously like they have launched. So from here itself we are going to be use this retrieval QA chain. But if you don't want to use this chain, if you want to use the latest thing, so in that case what you can do, let me show you the retrieval QA. I think here itself you will be able to find out retrieval QA. So retrieval QA with south chain, and see retrieval QA is here. So you can use it, you can use the other chain as well. You can see the differences and all. I'll be showing you inside the langchain series. Now here what I'm doing, so here I'm going to be search about this langchain expression language. So langchain expression language, and there also you can create this chain and all in a like latest manner. So all the thing actually you can combine using this pipe symbol, and here I can show you this particular one. So at many time actually I have shown you this type of thing and all. So prompt, model, output parser, everything we are going to be combine using this pipe symbol only. Now let me check whether I got the response or not. Yes, I got the response. So here I'm see, here is my response. So what is a rag token model? So here is my result, and inside the result guys, they have combined each and everything inside this chain. So that's why you can use the other chain, or you can use the this langchain expression language. Now let me show you the result over here. If I'm going to print the result, so first of all you will get the three output. Use the following piece of context question if you don't know the answer. So here it's a by default message which I'm getting. So this is my first context, this is my second context, and this is my third context. Now here is my question. The question is, what is a RAG model? Okay, RAG token model, and see the answer over here. Helpful answer is what? The RAG token model is variant of a standard autoregressive and all. So this I am getting with the this a particular answer I am getting with what? With the normal chain. Okay, so here you can see. Now here I want to show you the same thing with the hybrid search. So let me show you with the hybrid search, and you will find out that answer is a more meaningful. So let me take the response true and normal. Instead of this, I can take the hybrid chain, HIBRID, hybrid underscore chain. Okay, let me check whether name is correct or not. Yes, it is correct. So yes, it is going to be response 2. Now let me print this particular response, guys. So first I'm going to be printed, and then from this particular dictionary I'm going to find out the output. So where is my output, guys? This is my output, which I'm going to be collect from here. Just a second, and yes. So response to dot get, and here is what, here is the result. Now you'll find out, guys, this result actually it's a more accurate compared to the previous one. So let me run it, and here is response to dot result. Okay, get result. Now see, use the following context to the like further output and all. So this is the first one, this is the second one, this is the third one. Now apart from this one, you will be find out the tokens also. Okay, so see, guys, what is a RAG model? So here is a helpful answer. So see, let me show you. First retrieval, second retrieval, and the third retrieval. Now apart from this one, this is information is being ranked using the keyword. So first one, second one, and the third one. So here you will find out in total 6 and here we were only 3. Okay, so first one, second one, and 3 Now here is what, here's my question, and this is my answer. Now just read the answer. What is a RAG token? So it's a very like compact answer, and like real to near to the real time. And here you will find out the unnecessary information and all, which is not at all required. Okay, this particular one, the model predict the token separately based on the like and all. And here see, let me show you the answer. The RAG token model is a natural language generation, whereas a document form a retrieval corpus used to predict each tokens. Instead of using the same document, predict all the tokens. RAG model. In the words, the token. See, guys, how precisely like they have defined each and everything. Whatever I want, based on that only. If you are going to read this one, it's a little clumsy. So that is what I was trying to say, tell you, because here's we are getting a more context. Okay, more context. Now let's do one thing. Let's try to look over here inside the like here you will look into the document, and you can search whatever you want to search. Let's say I want to search about this abstract question answering. So my question is, what is abstract question answering? I'm just going to be replace it with this one. What is abstract question answering? And here is what, here is my question. Now here I'm going to be replace it. Now you will be find out, guys, which one is the more accurate. So this one or that one. Okay, you can test it based on the different context and all. It is up to you. Response one, print response, response two. So here is a response two. Now just read over here this abstract question answering. Here are no formula, nothing. Okay, anything is not involved. And see, MS Marco, NLG, BLUE score, and here is what, here is the Wikipedia alone, and all these thing is involved. Let's see whether we are able to get the same or not over here. So if you will look into the answer of this first one, so see, use the following information. This. The question is this one. What is the question? What is the like abstract question answering? And here abstract question answering is X-ray provides from abstract answer even the correct answer in not document. The higher accuracy is remote and RAG 11 accuracy. And see, guys, here is what, here is my answer. Now here I am able to fetch the more context. Okay, based on the keyword also. So I'm able to provide the I'm able to provide the lots of information to my model, and that's a like main aim. That's a main aim over here. My aim basically. Now, just look into the response too, and you will be able to find out the so many information. It is still fetching. Once it will be done, I'll be able to get it. Just a second. And guys, if you like the video, if you got something from this particular video, please hit the like button. Please write the comment, okay, because this type of content actually takes very much efforts and all. So yeah, you can showcase your support by liking the video, by subscribing the channel, putting the comment and all, sharing to your friends and all, whoever is required this particular lectures and all, because this rag and all this or this generative AI. It's a very useful as of now in every domain. So definitely you should learn it. So like response to guys, it is generating and it is fetching the information. It's taking time also. Let's wait. Okay, great. I got the information. Now this is like did it use, and here is the response from this one. Now see, one, two, three, and again one, two, three. So these are the thing. And here you'll find out how abstract question answer. See guys, it has given me a different question also. What are some challenge and address? Okay, okay. See guys, here if you will look into this one, it has given me like different answer also. So context, if you don't know the answer, okay, this one is first, second, and third. Now it is doing a question answering to itself. Top popular extractive, one, two, three. So this is the entire information which has fetched. What is the abstract question answering? What are some real life example of it? Okay, great guys. Now see how like useful it is. Okay, how useful this like hybrid system is, and it is providing me a lots of information, like lots of context. Actually, it is going to be collect from where, from the data itself, and we are providing it to the model. Now you can test it on your own level. Okay, on your own level you can test it and you can check. Fine guys, this is it for this particular video. If you like it, then please hit the like button and please subscribe the channel. Thank you guys.